What's up, guys? In today's lesson we're talking polynomial functions. A polynomial function is defined as if the independent variable, it's an x, if it's to a power that's higher than 2. Okay, so we have a third power that's called the degree. Really the only way to graph these, which you're not doing on the assignment, is you simply make a table and you just input 3 through negative 3. Integers 3 through negative 3. 3, 2, 1, 0, negative 1, negative 2, negative 3. Now, I'm going to put 3 in, then I'm going to give you the rest of the answers, the outputs. These are the inputs. These are the outputs. So I got negative 2, then I substitute a 3 in for x. Plus 1. And then I get negative 5 as my output. Then if I click the up and put 2's over the 3's, I get an output of 3. There's no pattern to this really, like there is with the parabolas. Then you put a 1 in, you're going to get 1. Then you put 0. By the way, 0 is easy. If you have x, if you're independent unit 0, these 3 just go away and you got 1. Okay. Then I would have to reset the calculator to do the negatives. Okay. But the outputs are 15, 55, and 133, just to save time. Now, I'm not going to be graphing any numbers with the hundreds. If I get an output of 100, I'm just not going to graph that coordinate. So on the x-axis, I'm going to go by 1s. And then to make 55, I'll just go by 10s. Okay. So the x's go by 1s, the y's go by 10s. So 3, negative 5. So 1, 2, 3. Remember, we're going by 10s on the y. So negative 5. 2, 3. So forward 2. And 3's right there. Okay, 1, 1. So you go forward 1. Remember 1 right there. It's going to be really close. 0, 1. 1 and 0 yielded the same output, so right there. Negative 1, 15. So left 1, and then 10, 15. And then negative 2, 55. So 10, 20, 30, 40, 50, 55. Now connect the points in the order you made them. So it's just going up that way, and then here it's going downward, okay? Now, I got a couple questions. This is what's called the end behavior of the graph. Now, the arrow means approach. X approaches positive infinity, so this way is positive infinity. As X approaches positive infinity, a sideways 8 means infinity. What is Y approach? Well, it looks like as x goes this way, the function's going down, okay? So then y, that's the name of the function, goes to negative infinity because it's going down. Now, how about on the other side here as x approaches negative infinity? Well, then the function's going up, so then y approaches positive infinity, okay? There's a reason for that. Okay, now the next one, f of x means y. It's the same thing, function of x, just another name for function. 3x to the fourth plus 4x to the third plus 3x squared plus 4x plus 1. So again, it's a polynomial because the x is to a power that's higher than 2. Okay. So 3, 2, 1, 0, negative 1, negative 2, negative 3. Then I simply substitute those in for the x. I've got the outputs. The 3 input yields a 391 output. When I put 2 in, I get 101. When I input 1, I get 19. When I input 0, I get 1. When I input negative 1, I come up with negative 1. That's just a coincidence. Negative 2 gives me 21, and then negative 3, 151. So all these outputs above 100, I'm just not going to graph. Okay. Now, 21 is the most extreme. So on the x-axis, we'll go by 1s. And then on the y-axis, we're going to go by 5s. Okay. So 119. So I go 1, 5, 10, 15, 20, and then 19's right there. 0, 1. So remember, we're going by 5, so 1's just close in there. Negative 1, negative 1. And then negative 2, 21. Okay, so 5, 10, 15, 20. Remember to go the right direction. It's positive, you're going up. So just connect them. It looks like a parabola, but there's a little hump in the middle. Okay. Now, x approaches positive infinity. This is the positive infinity side. Well, what's happening to my function as I go out that way? It's going up. So y approaches positive infinity. You just make a sideways 8. Then as we go negative infinity, it looks like we're also going up. Okay, so that way approach is positive. Now, one of the things you're going to be doing in the assignment is determine the end behaviors without having to graph it, because you're not graphing on the assignment. Okay, back page is blank. Now, here's the first thing you're going to be doing. Follow directions in the video, please. Write each polynomial in standard form. I'll explain what that means in a bit. Then classify it by the degree and the number of terms. Now, standard form means your exponents have to decrease. So I like to apply 1s in front of these as coefficients. That's just my way of doing it. What's the highest exponent you have? X to the 4th. Okay, so I write down x to the 4th. I just have one term with x to the 4th. It's a positive 1. Okay, then that's done. What's your next highest exponent? X to the 3rd. So you can put minus 1x to the 3rd. You can put plus negative 1. There is no x to the 2nd. Then after x to the 2nd, we have x. So now it's in standard form. That's how you do standard form. Exponents should decrease. 3rd power, 4th power, 3rd power, 1st power. Okay, so I write degree and terms. The degree is simply your highest exponent. It would be a 4th power. You just put 4. And the number of terms, we have 1, 2, 3. Okay, that's all. Okay, 5a to the 2nd power plus 3a to the 3rd power plus 1. So the highest exponent is a to the 3rd. Okay, and the coefficient's a 3. That's the only one I have. Then a to the 2nd, I have the 5a to the 2nd. And then there are no a's, and then plus 1. Okay, so degree. So the degree is the 3rd power, 3. It's your highest exponent. That's what a degree is. It's whatever the highest exponent is. And the number of terms it has, again, is 1, 2, 3. Okay. Next one, 3 plus 12x to the power of 4. So x to the 4th is your high power. It has a coefficient of 12. And then you just have the constant, which is 3. Okay. So the degree. Don't put x to the 4th. You just write 4 because that's your power, highest exponent. And the terms are 2. Okay. Okay, next problem. This one's kind of weird. We have 7x to the 3rd power minus 10x to the 3rd power plus 1x to the 3rd power. So the highest power is obviously 3, but we have 3 different terms of x to the 3rd power. So what I need to do is combine them. Okay, so I just take 7 plus negative 10 plus 1. Okay, again, all these have x to the 3rds, so I just add the coefficients. 7 plus negative 10 plus 1. That's going to be negative 2. And then really that's the only power. I mean, I don't have x to the 2nd, I don't have x, I don't have any constants. Okay, so that's it. Now the degree is 3. Okay. And how many terms do you have? You just have 1. Okay, that's one term. That's called a monomial. Poly has more than 1. Monomial means 1. Okay, next one. We have 1x to the 2nd minus 1x to the 4th plus 2x to the 2nd. So the highest exponent's x to the 4th. And we only have one term with x to the 4th, so it would be a negative 1. X to the 3rd we don't have. Then x to the 2nd. But it seems like I have 2 of those, so I combine them. 1 plus 2 is 3. And those have been combined, and that's the end. So the degree is 4, and the number of terms is 2. Okay, 4 because the exponent, and then you got 1, 2 terms. Okay, and the last one, 2x to the 2nd power minus 10x to the 2nd power. Okay. So x to the 2nd is my highest, but I have x second here and here. So since there are 2 of them, we combine the coefficients by adding them. So 2 and negative 10 would add to negative 8. Okay, that's it. So the degree is 2 because x to the 2nd, and then the terms, there's just 1. There's just one term. Okay, I'd like you to pause this video, please, and go do on the assignment numbers 1 through 5. 1 through 5. Okay, numbers 1 through 5, and then resume the video. Okay, hopefully that went well. Now the next one, determine the end behavior of each graph of the polynomial function. Now that's the end behavior is that infinity stuff on the first page. Now, how do we do that without a graph? Well, here's what you're going to do. First, you need to write it in standard form, okay? So x second is the high. This is your only x second. It has a 6. Then x comes before the constant, so it would be negative 3x or minus 3x, and then the constant, minus 1. So it has to be put into standard form first. Then you come over here, you put x, arrow, and put the positive infinity on that one, and then negative infinity on that one. Then comma, comma, and then you need to decide what the y approach is from each side. You're always going to set that up, but then the y's is up for you to decide. Now here's how I determine the end behavior of the function, because y is the function. Okay, first on the positive infinity side, that's the one going to the right, okay, so that'd be going this way. It's determined by whether your leading coefficient, it's called LC, is positive or negative. The 6 is the leading coefficient, okay, it's 6, it's positive, okay. So if that's positive, then y is going to approach positive infinity on the right side. Now, on the other side, the left side, this is a little bit confusing here. Okay, and if that was negative 6 in front, I would be putting as negative. The other side behavior depends on the degree. Okay, the degree is your highest power, which is a 2. Okay, it's a 2, x to the second. So these are the two important things. Degree's 2. Now the question is that even or odd? It's even. So if the even, you put match. That means the end behaviors have to match. So if that's positive infinity, this will be positive. This will be the same thing. Okay. If it's odd, they're opposite. But if it's even degree, they match. Okay, next one. Y equals 8x to the 11th power minus 2x to the 9th power plus 3x to the 6th power plus 4. Now you need to put this in standard form. So your independent variable, the highest power it is to the 11th. And the only x to the 11th I have is 8. Now the next highest power, x to the 9th. Okay, that's the only one we have. And then x to the 6. Actually, this one was already in standard form. Okay, then plus 4. So the exponents have to decrease until you get to the constant. Then x approaches positive infinity, x approaches negative infinity. Okay, you're always setting that up. Y approaches, y approaches. LC, the leading coefficient, that's what LC stands for, leading coefficient. The leading coefficient is 8 and it's positive. So guess what that means? It means on the right side, that's this side, the graph goes up, positive infinity. Now the degree is the highest exponent. It's 11. Well, 11 is an odd number, okay? So the end behaviors will not match. They will be the opposite. So if it's odd, they go opposite. So negative infinity. If that's positive, that's negative. Okay, next one, y equals negative 3 minus 6x to the 5th power minus 9x to the 8th power. So I rewrite that in standard form. So x to the 8's your high, and it's a negative 9. Minus means that's a negative. So negative 9x to the 8th. That's the only one we got. Then x to the 5th, okay. And that's it for x's, and then I just have my constant, minus 3. So x approaches positive infinity. You're always setting these up, okay? As far as how you get in these, I always write them, okay? Because there's two scenarios. Positive infinity on this side, negative infinity on the other. Okay, so leading coefficient is negative 9 this time. So if it's negative, the y is going to approach negative infinity on the right side. Okay. Now, the other end behavior is determined by the degree. Degree means the highest exponent, and that's 8. Okay? So it's even, again, which means the end behaviors of the graph match. Okay? So negative infinity and that, so not this, we go by this. Okay? So if I got negative infinity on the first one, I need to match it on the other side. Okay, next one. Y equals negative 8x to the 7th plus 16x to the 6th plus 9. So the highest exponent's x to the 7th. I just have the negative 8. And then x to the 6th would be my next highest, and I just have the 16, and then plus 9. Okay, so it was already in standard form. So end behavior, x approaches positive infinity, x approaches negative infinity. Okay. What is y approach? Y arrow, that's how you write that instead of approach. LC, leading coefficient, is negative 8. Okay, so since it's negative, it will approach negative infinity on the right side. Okay, it's just kind of rules, you know. And then degree. Degree is a 7th power. 7th is odd. Okay. So that means the end behaviors have to diverge. They go in opposite directions. So if that's negative infinity on that side, it'll be positive infinity on the other side. Okay, y equals negative 1 x to the 3rd minus 1x to the 2nd plus 3. So I think this is already good. I mean, I'll just make sure x third is your degree, minus 1. And x second would be the negative 1. And then your constant plus positive 3, so it was already good to go. So positive infinity, negative infinity. Y approaches, y approaches. LC, leading coefficient, is negative 1. So that means on the positive side of x, the function is going to go down. It's going to go negative infinity. Okay? Because that's a dominant term. And if the dominant term is negative, then this way, you will be going, as you pick higher numbers for x, the graph just goes down and down and down. Then, degree. Degree is a 3rd power, so 3. And that's odd, so the end behaviors have to be opposite. Okay, so this is negative infinity, so on the other side it does the opposite. It will go up, so positive infinity. Okay, and then the last one. Y equals 5 minus 17x to the 7th plus 9x to the 10th. So, highest exponent, x to the 10th. It's got a 9 coefficient, positive 9. And then x to the 7th is my next highest with a coefficient of minus 17, negative 17. And then my constant of 5. Okay. So x approaches, positive infinity, negative infinity. Okay, my leading coefficient is positive 9. Okay, remember these are the two that we look at. Okay, nothing else is really that important. So L leading coefficient's 9, it's positive. Okay, so we'll have positive infinity on that positive infinity side for x. Now the degree. Okay, degree is a 10. Well, 10's even. So an even degree of the polynomial means the end behaviors have to match. Okay, so the end behavior is positive infinity. We just match the end behavior. Okay. Now pause the video and go do 6, 7, 8, 9, 10, 11. Okay. Then the last part, or last two parts, these are easy. Find the zeros of each function. All this is just put it, it's in factored form. This is f, this is f2. You got to find the two values for x then that make the y equal to 0. It's very easy. X minus 1 could equal 0, or x plus 2 could equal 0. So plus 1, so I get 1. 1 is a 0. Minus 2, negative 2 is a 0. And that's all you do. 1 and negative 2. Okay, y equals x, parentheses, and put that x in parentheses, because that's an important factor when it contains an x. X plus 5, x minus 8. So this time I got 3 of them, and you're going to have more than 2 a lot of times. So you set your x equal to 0, that from there, and that's done, okay? So 0 is a 0. X plus 5 could equal 0. Subtract 5 and you get negative 5. X minus 8 could equal 0. Plus 8, you get 8. Okay. Okay, then the next one, F1, F2, F3. Okay, so x plus 1 could equal 0. And you get negative 1. X minus 1 could equal 0. You get positive 1. X minus 2 could equal 0. And you get 2. Okay, so negative 1, 1, and 2. Okay, pause the video now and do 12 through 14. Okay. Then the final part is pretty easy. Now you're given the zeros and you have to write the function in factored form, meaning you can just leave it in parentheses. Okay, you don't need to multiply it out with the given zeros. So now they told you the zeros, you have to get back to the equation. So y equals, then you make a parentheses. First 0 is a 5, so x, and then you always put minus 5. If it's a negative, you'll switch it to plus. X minus 6, x minus 7, donezo. Okay. Next one, 2, 2, and 5. So be careful here. X minus, and then you're going to put 2. But then I have a repeated 0. It's called a multiplicity of 2. Okay. When you have a repeated, you just raise that factor to the second power, okay? And then x minus, and then 5. Okay, next one. Negative 5, and 1. So we always start off with x minus, but if it's a negative, we make the minus plus and just put 5, okay? And then a second one, we'll just raise it to the second, then x minus 1. Okay, now what if you get 0? Well, here's what you're going to do. You're just going to put x, okay? You don't need to put minus 0. And then x minus, and then a 4. X minus, okay, a negative 6 would make it plus 6. Okay, there you go. Okay, 1, negative 2. So y equals x minus, put a 1. X minus, and a negative 1 would be plus 1. And then x minus, and then plus 2. Okay, remember what I told you to do is 0. You just put an x in parentheses by itself, but since there's 2 of them, we'll just put that to the second power, then a parentheses with x minus, and then 12. Okay, then 0, 4, negative 1/2. The negative 1/2 is interesting because there's something they want you to do. Don't worry too much about it. So you got an x and you're just going to put x. X minus, then put 4. X minus, but we're going to make it plus because the 0 is a negative, so plus 1/2. Now, one thing they want you to do is if you end up with a fraction being added, you take away the denominator and place it in front of the x as a coefficient. So 2x plus 1. Because if I minus 1, it'd be negative 1 over 2. Okay. I don't think that comes up on the assignment. Okay. And then you're ready for the last page.